Suhyung Jang from Yonsei University, Seoul, Korea, and I just received my PhD from last February from my supervisor who's here, Dr. Ghang, and this research was initiated by what was missing in my PhD dissertation. So mine was about design detailing automation, but the question was that what if we don't even have a BIM model like that's in probably like LD 100 or 200. So today's like presentation would cover some of the interim result of like ongoing project to enable AI models to interpret and further generate early stage BIM models. So according to AI Report 2025 from Royal Institute of British Architect, that almost 60% of the design firms are already using AI in their daily practices. And also like in academia, in recent decade, there has been extensive studies conducted to automate the design processes, not to replace, but to support too. But the main focus, which is almost like 70% of the studies, was on schematic design, and particularly in building layout generation, which has accounted the largest amount of the studies among them. And various floor plan data sets, which includes R-Plan, Lightful, and MSD, was constructed to support this area where the building layouts are interpreted and generated, and there has been many dedication from researchers. However, we still have remaining challenges of utilizing these floor plan-based images to interpret and generate building projects, because those image-based plan data, like which often lacks the vertical context, I mean, that's a second challenge, but is limited in representing those complex variations and the configurations of the spaces and programs, which we often have like multiple floors of the building. And first of all, we have to label those rooms and connections like within the images, and that's labor intensive and also error prone. So to provide some background knowledge, so why do we have to make those building descriptions? So to provide some like background knowledge about like those who are not familiar with image captioning and generation, we train like generative AI models like nowadays, utilizing extensive amount of data set, which is image and their paired description, which we call them image caption. So the task of image captioning is where we input image to the AI model and get the relevant description out of the image. And conversely, when we give those description and get the image, that's what we call image generation. So the long-term goal of our project is to enable AI models, only giving them like description of the project that we want, and get those BIM models that's in the early stage. I'm in early stage by like LD 100 or 200, so I can apply what I've been proposing like during my thesis for design detailing automation. So today's presentation is going to be like more focused on the earlier stage in overall, which is developing a method to automatically generating project descriptions out of BIM models that we already have. So just as, for example, like Jijen just showed in the last presentation, we already have like plenty of BIM models, and now that we can utilize them to train AI models. So the proposed method comprises 3 steps, which is extracting topological and programmatic metadata, and structuring for LLM interpretation, which I use large language models to make those descriptions, and then finally generating those building design descriptor, which are relevant to the certain design characteristics that we are interested in when we are making new project. So briefly explain the first step. We extract the spatial element and the connecting element, which we call here are windows and doors and stairs, which interconnects spaces like indoors and outdoors vertically and horizontally. And then we parse metadata from spatial elements and also geometries. And from the geometry calculation, which we utilize threshold-enabled triangle intersection algorithm, which is just efficient mesh intersection calculating algorithm. And then we parse those spatial connectivity that is labeled with the metadata. Then we utilized JSON as a data format, which we represented those spatial elements and the connecting elements and actual connectivity that's parsed from the algorithm and represent them as one JSON file. Oh. And then from the JSON file, we provided large language models, the whole file, and also instructions that is related to the design characteristics such as spatial configuration and area proportion and levels and circulation and room geometries, and which is extensible, but still those are like what we use in this round of stage. And I prepared a simple demo that might better explain than what I've just explained. And from this simple BIM model, we can parse those spatial elements and the connecting elements and their connectivity. And then from that, it's only visualization, but they're in like extracted format. And then we can structure it as a JSON format text data, which is easily interpreted by large language models. Then through instruction prompting, we can parse those design features that we are particularly interested in, such as connectivity or like circulation and their like levels. We did a simple case study to validate the proposed method, and we generated project descriptions out of BIM models that we have to evaluate if there's any omissions or errors in terms of the number of the rooms that's included in the BIM model, and also the gross floor area, if there's any changes that's like parsed from the BIM model. And then we evaluated also incorrect descriptions. I mean, like this wasn't really done like robustly, but we had looked into all the descriptions that's generated by large language models and identified if it doesn't match with the BIM models. So from the results, although like there existed some differences between the language model that's selected, we could identify some potentials that through this method, we can get some description that it is actually describing the BIM model that was input. However, there still, of course, remains rooms to improve. So these models, like both were successful in describing overall configuration of building in these spaces, but they also had like flaws in details, such as, for example, when I used the OpenAI-o1 for that project, it described the building to have some clustered toilet in the configuration, but it actually doesn't in the model. And it was like close enough, like DeepSeek was like close enough to describe the space was surrounding a cinema room, but it like mentioned that it was like looped plan that's like surrounding them on like all four directions, but actually it didn't, but it was like close enough. But still, we need those like robustness to use them as a training data, so that's something that we need to improve more. So to conclude, we propose a method to automatically generate those building descriptions out of readily existing BIM models. And as I mentioned, we also have a long-term goal of generating BIM models only from project description that architects or owner might have. And I hope to show you some progresses in generating in next presentation. And before I conclude my presentation, I want to mention that this work was supported by Hans Fischer Senior Fellowship Program at the Technical University of Munich that was awarded to my supervisor, Professor Lee. And that concludes my presentation. Thank you.